Hello, and welcome to my office. Today I have a visitor, namely Ivalu Christensen.
Yes.
Yeah, from Max Planck Institute.
Yes.
Very fancy.
Mm.
And we'll be speaking English today, even though Ivalu and I both speak Danish. But I'm sorry, I do not speak Greenlandic.
Yeah.
I
It's a
hope
hard language.
it's a hard language, so
Yeah.
we'll keep it in English. So welcome, Ivalu.
Thank you.
What are you up to these days?
I am finishing up my PhD from the Max Planck Institute for Radio Astronomy.
Wow.
Yeah.
Yeah. So you're just at the edge.
Yeah.
So you didn't have your defense yet.
I'm just waiting for that now. Yeah.
Wow. Yeah. So what's your PhD about?
My PhD is looking into the chemistry in star-forming regions. So what I'm specifically looking at is these molecular clouds. So they're very cold. They're like negative 200 Celsius degrees, approximately 20 degrees in Kelvin. Um, on these regions, they're very exciting and they're very colorful, and they have a lot of interesting molecules in the locations. So what I'm specifically looking at are these molecules that contain the heavy hydrogen, so deuterium. And I'm looking at if there are any differences in the locations where the different deuterium molecules can be found.
Uh-huh. Yeah. So when we see these colorful, beautiful pictures, those are the things that we're looking at actually without realizing, maybe.
Yeah, so they're colorized, a lot of them. So lately, James Webb Space Telescope has come out with like these beautiful molecular clouds where stars are forming. But in radio astronomy, so we're looking at the wavelengths in radio frequencies. So in these regions, we have to colorize them ourselves. So we can't see the colors, but we give them colors. And for my research, I use purple a lot because it's my favorite color.
Wow, so it's like being an artist.
Yeah,
Yeah, you can
exactly.
actually choose. You have the freedom to choose the
Yeah,
colors. Yeah,
yeah,
but
exactly.
not the patterns and so on, of
No,
course.
not the patterns. Yeah.
So wow, yeah. So that's basically your core topic, and you've been
Yes.
working with this Cascade project
Yes.
about
So
Cygnus.
yes. So it's one specific molecular cloud called Cygnus X, and it's 5,000 light years away from us. And right now, there's a lot of stars forming actively on it, and a lot of these are massive stars. So stars that are gonna be 10 times more massive than our sun. What we're interested in looking at is how the conditions that lead to these big stars to form. Um, so I'm looking at the chemistry of it. My coworkers, my colleagues, they're looking at how the gas is moving around and how like these newly formed stars are affecting the environment.
Yeah.
Yeah.
So these will be stars like my favorite star, perhaps Betelgeuse,
In many, many millions of years.
in many
Yes.
millions of years.
Yeah.
Yeah.
So right now they're actively forming,
Yeah.
and this we say it's a short period of time, but it's over millions of years
Yeah.
still. So we're looking at like a tiny split second in this scheme of like stars.
Yeah. The life of stars.
Yes.
Yeah. So I just thought of one thing that we didn't talk about this before, but recently there were some suggestions that Betelgeuse may actually have a partner star. So
Yeah.
most stars are binaries or tertiaries or quadruple stars, really, not like our sun, which is a singleton. But even giant stars, of course, can have siblings. So what do you have any thoughts about that?
So what they have done with Betelgeuse, which is in the Orion constellation, is that they've looked at it in radio wavelengths also, and they've seen that it looks kind of weird. It's not round. There's like a little blob,
Mhm.
and they've suggested that that might be a companion star.
Yeah.
But Betelgeuse is a very hard star to look at because it's at the end stages of its life.
Yeah.
We don't know when it will explode, but it's been showing some very interesting signs in the past 5 years or so, where the light has dimmed very much and then become brighter again, and now it's kind of calm again.
Yeah.
So we don't know what's happening to it, and we don't know at what stage of its end it is.
Yeah.
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 But there might be a companion star.
Wow. Yeah. Well, if you've been watching my channel, you would also know that maybe they even have star spots, because that's been my kind of topic. But well, so your topic's not Beetlejuice, so
No.
sorry to derail you. What are you going to do in the future? What do you think is what's the goals that you want to achieve after the PhD?
Yeah, so far I've been looking at how these deuterium molecules are behaving on a cloud scale. What I want to in the future look into is looking at the regions where stars are actively forming at different stages of its formation, and then see how the deuterium abundances, like how much of this deuterium molecules there are in the different stages, if it has an effect on the stars forming, or vice versa, if the stars forming has an effect on how much of this deuterium molecule there are.
Okay. I was thinking that the deuterium abundances on Earth.
Mm.
Where does deuterium come from?
So deuterium as an atom was only formed during Big Bang. So everything, all the deuterium in the world, in the universe, actually was formed back then, 13.7 billion years ago. And then it can only be destroyed inside stars. What they can do is they can move around and then concentrate on different regions. And interestingly, they do in star forming regions, which is like up to 100% more than what it is in the regions outside of molecular clouds.
Oh, wow.
Yeah. So everything that we have with deuterium molecules and anything with the deuterium atom in it, it's from the Big Bang.
Basically, so even the heavy water in Norway that may be used in nuclear reactors and stuff like that, it owes its existence to the Big Bang.
Yep.
And not having been destroyed in stars that came before the sun.
Exactly. Yes.
Wow.
Yeah.
Well, that's a thought. All right. So what are your long-term hopes and dreams to do in science? Are there any big questions that you want to solve?
Yeah, I'm very interested in looking at how timescales affect molecules and how molecules affect the evolution of things. So I'm very interested in looking at chemical evolution in star forming regions. And it's a very big question. It's an open-ended question still, because there's a lot of molecules in space. So yeah, there's a lot of work to do.
There's a lot of work to do.
Yeah.
Okay, I think with that we should conclude. So I wish you the best of luck for your PhD and that part of the whole story, but also solving the meaning of the life, the universe, and everything when it comes to molecules in the future.
Yeah.
Thank you for coming.
Thank you.
Thank you. And bye-bye.
Bye.